For my part, I will explain question 1, Roman 1 and Roman 2. The question is, for a monopolist, the average cost of producing a unit of the product is 3 ringgit. And the demand equation is P equal to 10 divided with X squared. Find the total profit function. As you know, to find the total profit is equal to total revenue minus total cost. Therefore, we need to find the total revenue function and the total cost function. So we get the total revenue function by multiply price with quantity equal to 10x squared. For the total cost function, we multiply average cost with quantity and we got 3x. So our final answer for total profit function is 10 squared minus 3x. This question is, what price gives the greatest profit? So to answer this question, we have to find the critical value by using the application of the first derivatives, the first order condition. So firstly, we need to find the first derivative for the total profit function, and we get 5x power of negative 1 per 2 minus 3. And we solve for x to get the critical value. So 5 power of negative 1 per 2 minus 3 equal to 0. First, change the place of negative 3 to right, followed by 5. And we got x power of negative 1 per 2 equal to 3 per 5. Then we change the negative sign of x power of negative 1 per 2 into 1 per x squared. Okay, now we use cross multiply by multiply 5 with 1 and 3 multiply with x squared to get rid of the fraction. Then we get 5 equal to 3x squared. Change 3 to the left and we get 5 per 3 equal to x squared. Now to get rid of the square root, x equal to 5 per 3 square, then the critical value we got is 25 per 9. Now we substitute 25 per 9 into the demand equation and we got 6. In conclusion, our final answer is, price give the greatest profit is 6 ringgit.
To prove that the profit is at maximum, using the second order condition, first, recall that the second order condition for a maximum require that the second derivative of the function be less than 0 at the critical point. Given that the function for profit, which is 10 times the square root of x minus 3 times x, we need to find the second derivative. Get the second derivative as negative 5 half times x raised to the power of negative 3 half. Determine the value of second derivative at critical point. Evaluate the second derivative at critical point, which is 25 divided by 9. Substitute x equals 25 divided by 9 into the second derivative. The second derivative becomes negative 5 half times 25 divided by 9 raised to the power of negative 3 half. This simplifies to negative 5 half times 9 divided by 25 raised to the power of 3 half. Raising 9 divided by 25 to the power of 3 half, we get 9 divided by 25 raised to the power of 1 and a half. This further simplified to 27 divided by 125 by multiplied by negative 5 half. The second derivative at x equals 25 divided by 9 is negative 5 half. Time 27 divided by 125. This simplified to negative 135 divided by 250. Further simplification gives negative 27 divided by 50. Negative 27 divided by 50 is less than 0. This confirms that the profit is at maximum at this point. The total cost function can be determined by summing this individual costs. For example, the total overhead cost, which is 6,000 ringgit. Total material cost, which is calculated by multiplying 5 ringgit by the numbers of unit produced. And the total labor cost, which is calculated by dividing the square of the numbers of units produced by 60. Therefore, the total cost function can be expressed as the total cost function is equals to 6,000 plus 5 times the numbers of units produced plus the square of the numbers of unit produced divided by 60.
I will explain about how to find the answer for B2. The question is find how many units must be produced so that the average cost is minimum. To find the number of unit X at which the average cost is minimum, we first need to express the average cost function and then differentiate it with respect to X to find the critical point. And the average cost AC is given by the total cost divided by the quantity produced. So ACX equal to 6,000 plus 5x plus x squared over 60 divided by the x. So ACX is equal to 6,000 over x plus 5 plus x over 60. Now, to find the critical point where the average cost is minimized, we can differentiate ACX with respect to x and set the results equal to 0. So ACX equal to 0. Let's find ACX. ACX equal to d over dx, which is differentiation. Bracket 6,000 plus 5x plus x squared over 60 divided by the x. And simplify, set it equal to 0 to find a critical point. Solving this equation, we will set the derivative of average cost equal to 0. 6,000 plus 5x plus x squared over 60 equal to 0. And to solve for x, we have to multiply both sides by 60. To clear the fraction, we will get 36,000 plus 300x plus x squared equal to 0. Now, we shall factor the quadratic equation, which is bracket x plus 600 and bracket x minus 600 equal to 0. This gives the solution, which is x equal to 600 or negative 600. However, since the number of units produced cannot be negatives, so we have to discard x equal to negative 600. Therefore, the correct answer must be x equal to 600. We will proceed to question B3. Within the interval, find the interval where the average cost function is increasing or decreasing. First, we need to write the equation. The equation is 6,000 over x plus 5 plus x over 60. Then we differentiate it and we will get 6,000x negative 2 plus 1 over 16, and let AC prime x equal to 0. Then change the position and the final answer we will get the 600. We will get two intervals, which is 0 to 600, and the second interval is 600 to infinity. For the 0 to 600, I will use 500 to test, and then the 600 to infinity I will use 700. For the 500, I will get the negative, and for the 700, I will get the positive. So increasing for the 600 to infinity and decreasing for the 0 to 600.
How about the question 4? Find the rate of increase in total cost. We can find that Cx equal to 6,000 plus 5x plus x squared plus 60. Then we will do dx, then 5 plus 2x plus 60. Then we can get the answer is 5 plus x plus 30. So question 5 is refer to answer 4, expand your answer. So my answer is the rate of increase in total cost dx tell how much Cx change with respect to the number of unit X product. Specifically, dx equal to 5 plus x per 30. This means that for every additional unit product, the total cost increased by a base amount of 5 ringgit, which is material cost, plus an additional amount that grows linearly with the number of unit product, which is x per 30, and it is labor cost. As production increase, the labor cost contribution to the total cost increase become more significant. Thank you.